Hi guys, let's talk today just a little bit about Pearson correlation coefficient, just in case any of you all are confused. You want to look at step 2 under part 3. You're going to look at the data table. That's where I'm going to be pulling these values from. So I'm going to do the Pearson coefficient for Mike Smith and patient 2. Okay, now Mike Smith is going to serve as our X, okay? Patient 2 is going to serve as our Y. Now, you will have to do this for 4 different times. You'll do it for patient 1, 3, and 4. I'm going to do patient 2, and then you can go back and do the others. There is a lot of work to it, okay? I'm going to write it out long form, and it's going to take a lot of writing. Now, you may just be able to do this in a calculator and not have to do all the steps, but in order to show it to you, I'm going to do all the steps. So the first thing I want to do is I want to calculate the mean of the values for Mike Smith. So Mike Smith again is X, and I'm calculating the mean, which is the average, and so that's the X with the line over it. So I'm going to look at Mike Smith, and I'm just going to go those numbers down his table, down that column. So 0 plus 3 plus 3.58 plus 4 plus 3.58 plus 3. And then to find the mean, I'm going to divide it by the total number of values, which is 6. And that's going to give me 2.86. That's my average or mean for Mike Smith. Okay. Now, I'm going to do the same thing for patient 2. So patient 2's values were 0 plus 2 plus 3 plus 3 plus 3 plus 3. And then I will divide that by 6 as well. And so for patient 2, I get 2.33. Okay, so those are the two numbers that I'm going to be working here. So this is kind of step 1. Okay, now in step 2, I'm going to compare Mike Smith with patient 2. And so what I'm going to do is I'm going to take each of those values for Mike Smith, each of these, 0, 3, 3.58, 4, so on and so forth. And I'm going to subtract 2.86 from them. I'm going to subtract his average from each of the values. So 0 minus 2.86, 3 minus 2.86, 3.58 minus 2.86, 4 minus 2.86, 3.5, oh no, sorry, 3.58 minus 2.86, and then 3 minus 2.86, okay? And I'm going to do the same thing for patient 2, subtracting his from his value. So again, this is Mike, this is patient 2. So his values right here were 0, 2, 3, 3, 3, 3. And then I'm going to subtract them from, subtract 2.33 from them. Okay. And then let me just write in these answers here. Negative 2.86, 0.14, 0.72, 1.14, 0.72, 0.14, 2.33, negative 0.33, okay? And so that's what we should have so far in step 2, okay? Now, what I'm going to do is I'm going to multiply the values for Mike and patient 2 together for each gene. So I'm going to multiply negative 2.86 times negative 2.33, 0.14 times negative 0.33, okay? This is going to be step 3. So negative 2.86 times negative, 2.33, okay? 0.14 times negative 0.33, 0.72 times 0.67, 0. scratch that, 1.14 times 0.67. 0.72 times 0.67 and 0.14 times 0.67. So then I'll get all of my answers here. So 6.66, negative 0.05, 0.48, 0.76, 0.48, I keep doing that. Glad I've got a undo button, 0.09, okay? Now, in step 4, what I'm going to do is I'm going to take the sum of these numbers. So add all those together, 6.66, and then add them in as negatives. And what I got when I added all of those up was 8.42. 8.42. All right. And then in step 5, I'm going to go back up to step 2, and I'm going to square all of the numbers from step 2. So these guys, I'm going to square them, okay? Negative 2.86 squared, 0.14 squared, 0.72, all of those, I will square them in this next step and take the sum of those, okay? So when I square the first number, negative 2.86 squared, I get 8.18. The next one I get 0.02, 0.52, 1.30, 0.52, and 0.02. And then I take the sum of those, and I got 10.56, okay? Again, this was for Mike's column. All right, now I'm going to do the other side. I'm going to square all of these. Oh no. Well, I just lost all of that. I'm going to square all of those. So let's keep going. 5.42. Once I square it, negative 2.33 squared is 5.42. And then I have 0.11, and I have 0.45, and 0.45, and 0.45, and 0.45. After I squared all of those from patient 2, and so when I add those together, I get 7.33. So over here, when I'd added those together, I got 10.56. Let me just rewrite what they were. I'm not going to rewrite all of the above stuff, so hopefully you have that written down. Okay? And so I've got 10.56 for Mike. I can't believe I deleted that. And then 7.33 for patient 2. Okay? So this is our step like 6, kind of. Okay? So now what we're going to do in step 7, we are going to multiply those numbers. 10.56 times 7.33. And what I got was 77.4. Okay? Step 8, I'm going to take the square root of 77.4, and I get 8.80, okay? Now, this is going to be the denominator, and I'm going to go back up to step number 4. In step number 4, I had added all of my values up when I multiplied Mike and patient 2, and I got 8.42. That is my numerator. Okay, and so I'm going to put 8.42 over 8.80, all right, and then that is going to give me, sorry, my laundry is kicking off, my Pearson correlation coefficient for Mike Smith and patient 2, and I got 0.957, okay. Now, you will also get other numbers for patient 1, patient 3, and patient 4. You'll have to do these steps for all of those patients, okay? The one with the highest Pearson correlation coefficient is the one that the chemotherapy drug that patient used will work best for Mike, okay? They have the genes that were basically the same. So, for example, let's say that it's patient 2, that's the highest Pearson correlation coefficient. We know that whatever this drug drug 2, we're going to call it, was given to patient 2 and it worked and it cured his cancer. So if Mike's genes are very similar to patient 2's genes, meaning they show a high correlation coefficient, then we are going to want to give him the same cocktail of chemotherapy medicine. Because if it worked for patient 2 and Mike's genes are very similar to patient 2, then we could also conclude that it would probably work for Mike. Okay? So, but you have to do the other patients as well to determine which one has the highest correlation coefficient. The highest correlation coefficient is going to be the best. Okay? So, let me know if y'all have any questions on that, and I hope that was helpful.